couple of days ago, this was a bare block. Now in this video, we're going to go from the short engine to what you see in front of you. So, let's see how it went together.
Well, hello, and welcome back to Red Fox Classics. Sat next to me is the engine for my Triumph Spitfire Mk3, which is hiding under the cover there. Now last time we built the short engine, more or less. So the pistons are in, cranks in, cams in. Just popped the sump on, and what I wanted to do was check the end, find a 5 thou oversize frost washer and check the end flight crankshaft again. And I did some hunting last night, and I actually have one, which is good. I also did a quick check of the camshaft end float, and it was just in spec. So I also found I have a spare keeper plate, which was too large to fit in my Herald when I built that engine. So they wouldn't actually fit in the slot on the cam. However, I think it will on this one, and it might help us out. So, start off, get those 2 end floats checked, then we can start working on getting the timing done. And to do that, got to sort out the alignment of the pulley that goes on the cam and the pulley that goes on the crank, because they need to be in line. If they're out of line, you've got stresses on the timing chain because it's pulling one or the other of those pieces in, diagonally. We don't want that. And when that's done, we can time the engine and get ready to put the head on. Let's check those end floats and get on with the rest of it.
So you see I've already got the dial gauge set up on a cam. 0 there. If we pull the cam all the way out, we're at 0.215 millimeters, which is just in spec. But I'm hoping, with this slightly wider keeper plate, we can bring it a bit closer to the mid-range of that spec. So I'll change the look. Stick the dial gauge back on. It comes all the way in. All the way out. That is actually just at the other end of the scale, so we need 0.8 mil, and close to 0.7 there. Parallel to the face. I think perhaps we're a little tight now. Don't really want to be trying to take material off of this, because chances of me doing it straight are probably minimal. Jolt up a bit more. Makes it worse. We're going to have to put the original back. And somehow taking it off and putting it on again, we're now more in spec. We're 18.18. It's fine, okay. Whatever, we'll take that. I'll flip the engine over, we'll do the crankshaft, see if that's as mysteriously different. Okay, pop the sump off. I went for red, by the way, as at some point the whole of the car was painted red, the outside and most of the engine bay, including the radiator. So I thought it was, I don't know, it's a bit funny. Or it amuses me slightly to paint some of it red again. Anyway. Okay, before I fiddle with anything again, I'll just give myself a sanity check. I've gone and got the pulley nut because trying to get this dial gauge set up on the end of the crankshaft was causing me all sorts of problems because it wasn't sitting quite right. Yeah, quite right against the end because it's not a flat surface. I was getting different readings every time I did it. So that's all the way back and all the way forwards. So in millimetres, our spec is 0.1 to 0.2, and we are too big there. So perhaps previously I wasn't reading it right. Anyway, I will nip off the cap on this rear shell. We'll pop the other thrust washer in and see how that goes. So we can get this rear one out. Okay, we don't need to pull it out first, we should just be able to swap them if we can get the crank to turn. Not even that. Again, copper side to the crank, because that's the thrust face. Yeah. Cap back on, it is the right way round, with dots and dots. Not torqued it, but I'm going to see what we've got. Back. Oops. And all the way forward. Okay, so that puts us more happily in the middle of the range there, between 0.1 and 0.2 mil. Three. Okay, so that's better. Glad I did that. So let's, what do we have to do now? Get that torque back up again. Chuck the engine, chuck the sump on, turn the engine back over. And we'll get on with the bits on this face. Right, so the point here is to get the gear on here and the gear on here lined up as best as possible. Now, this has a chamfer on that side, and that's got to go up against this face. I'm going to check myself on that, but I'm pretty sure, because that is not that's not a sharp corner. So we need to accommodate it. Don't think it would actually go flush against the face with this bit. Anyway, we'll find out, because if that's wrong, absolutely won't line up. And there's a burr on the edge of my Woodruff keyhole. I'm pretty sure this can only go one way as well. I don't think it can go that way on. Can it? Really? Definitely can't go that way around. Okay, so These teeth and these teeth need to be lined up. Now, bearing in mind we have end float on both of those, both the crank and the cam. Excuse me. So the way we can look at this is like that. So you can see there is quite a large difference in alignment between these two sets of teeth. So that means need to shim behind here. If it will come off. There's a little bit of a problem we have here because the shims you get are the same diameter as this shaft. However, as we had a look before, it's not a 90-degree angle between this shaft and the bit that the gear rests on. So if you start putting in shims, you're not going to get a proper reading without putting the pulley on and the knot and tightening the whole thing down so it's all squashed together. And at that point you've ruined your shims. So, well, not ruined them, they're fine as they for their application, but it'd be difficult to reuse them elsewhere anyway. So what I'm going to do is just stick some feeler gauges behind till we get the right sort of line up. So that was 12 and 15. So now I'm quite close. I just want to look and see if I can see light between, if I lay my straight edge, yeah, I can just see a line of light where my thumb is. No, I can't. Now I can feel rocking still. Really? That looks like it wants to be a long way out. And I suppose we have got aftermarket parts versus aftermarket parts. The cam's non-standard and the gear's non-standard and non-original. I'll try something different. So I set my dial gauge, hopefully, on the pulley. Do it on the other side. It's going to be more visible for the camera than for me, but again now I can just pull this gear out to where it wants to sit. And I should be able to read off. So my ruler is now not rocking. So that is 0.36 millimeters, which is apparently 14 thou. So have we gone all the way round? Yeah, we have, haven't we? So we're on 2 thereabouts on that dial. Is that one full revolution then to, I think that's now 1.16. Should be 45.6 thou. Should we reckon 25. Yeah, we don't have 50 by feeler gauges. So I think let's try it with some, I think we're going to have to put it together, tighten it up. Now luckily, I've got some of these. However, these shims are listed as no longer available, but if you look for 1 1/2 inch arbor shims, somewhere like that, then you get the things you need. So that's exactly what these are. Now these are 12 thou, and the advantage to the newer ones is you can buy them with the keyway, so you can actually do this with the woodruff key on if you need to. So that's 4 12s, 48 and a 2, so that's at 50. Actually, no they're not. That Unipart bag had a mixture of shim sizes in, and I had only measured one and assumed they were all the same because they had one part number on it. So that led to some confusion. Anyway, we'll skip past that bit and get to when I figure it out. So what had happened here is I've been an idiot. I had this pack of shims, and because they had a part number stuck to them, and I thought they were sealed, I thought they were all the same. And I measured one, and that was 12 thou. Now I've just taken them all out, measured all the rest. I had 6 that were 6 thou, 2 that were 5 thou, 1 that was 12 thou. So I've now got a sensible shim pack here. Well, it's still very large, but it means that we're going to get alignment between the two gears. Don't assume that stuff in old packets is actually even what it says it is. Right, so on to timing the cam. Now, the whole thing here is we've got our crankshaft and our camshaft, and they need to be aligned in a particular way so that the camshaft opens and closes the valves at the right point relative to where the pistons are. Because obviously we need, when we want to fire, we need all the valves closed, and when we need to get fuel in, they all need to line up. Now the principle is actually quite easy, because all we need to do is set the crankshaft at a particular angle, so relative to top dead centre. We turn the cam until we've got an intake, or the intake lobe on cylinder 1 is fully open, and then we have to connect the two together. Now, the complexity comes in finding exactly where top dead centre is and exactly where the top of the cam is. And that's because, you think of our cam, it's sort of that shape. And it's easier to think of it as being 2 circles. So this is the bit that pushes on the push rod and opens the valves via the rocker arm. And we need to find that point. But as this is a circle, when we're there, it's all going to seem quite similar when we're measuring it. So there's going to be a point, probably like there to there, where we can't see any movement when we're trying to measure it. Same applies for the pistons, because they are travelling on a similar axis. But theirs is a bit more like an oval, or a lozenge sort of shape. Anyway, so in order to do this, we actually take our measurements, somewhere here and somewhere the equivalent space the other side. And yes, this now looks like a cheering little person. But we measure where we know we're going to see a big difference, and then we take the middle point between those two. And the same principle applies for the cam and the crank, just measurement is done slightly differently. So we'll go and start with the crank. For that, I've made a device. It replaces my previous attempt, which didn't survive very long. I managed to make it work for the hell of them. Anyway, just dug out my kit. 2 old tappets, which I'm popping in there. Some old push rods with washers and springs. So these are going to sit, in our tappets, and then that plate, which has holes to hold those push rods in one place. I'm going to get it bolted to the cylinder head. And then we've got this bit in the middle. So these are for the cam, we'll ignore them for now. So this is a piston stop. So it's going to stop me turning the piston, and it's going to give us that range of, you know, the two further parts of the circle. So we've got the disc on here. Final thing, which is a pointer, also known as a bit of coat hanger. That gives us something to read against. Now, so what I'm going to do is bring the piston up till it hits that stop and read where I am, which is in 25 degrees after top of the centre. And then I'm going to go all the way around till we hit again, which is then 22 and a half before. This is before top dead centre, isn't it? Yes, because we're, yeah, we have rotation marked on as well. So it's 22 and a half and 325. What we're looking for is where the middle of those two is. So that goes the midpoint of those two numbers is 28.75 degrees in this direction. So that means that top dead centre should be when this pointer is pointing at 28.75. So undo the clamp I've got at the back. Should be able to rotate this disc, but not anything else. Yep. I was starting at 29. So now if I rotate all the way back around again, we should be hitting the same figure on this side. And we are. Okay, so this disc, this 0, now tells us where our top dead centre is. Next we need to do the same for the cam. We do that with the dial gauge in a similar manner. What I need to do first, put the chain on, because we need to actually have the ability to link them together once they are in the right place. And be able to wiggle this all the way around. Probably not. We know where we have to put that back to. So that can go, that can slip off. Let's put our pointer back in the right place. So just check if we go all the way back around again. Slightly out. Right, finally. What we do? Okay, so what I've done here is turned my crankshaft attached to the camshaft until my reading here won't go any higher. So either way I turn the crankshaft, the camshaft is going to drop. So we're almost at the top, or as close to the top of the camshaft lobe as we can get. So now, with that set to, again, yeah, so 0 is in the right place. Now I'm going to keep turning it till my dial gauge shows we've dropped a certain number of millimeters, and I'm going to go for basically 1 full revolution of this to 0 again. Then the number of degrees I'm reading on my degree wheel is 141.5. I'm going to go back, do the same thing. 1 full revolution of this dial gauge, back to 0, keep going till we'll go back again, and then I have to reapproach in the natural direction of engine rotation. Try and get that back onto my 0. And that gives me 54.5, or 55, which gives me 95.5 as my midpoint of the lobe on the camshaft. So I'll go to 90. Half. We're still at 0. And now camshaft should be pointing straight up on that intake lobe. So now what I have to do is detach the crankshaft from the camshaft. And now when I turn my crankshaft, it's not connected to the camshaft, so I want to get it to 110 degrees after top dead center, because that is when my intake should be fully open. So almost top dead center, so we need to be somewhere. The markings are all in before top dead center, of course. So no, this is after top dead center. Okay, so 110 on the blue scale. So now crankshaft's in the right position, camshaft's in the right position. We've got to make this gear agree. And you know what? It's not actually far off. So I'm going to see if moving it 1 tooth round will do. Okay, it does. We've got very lucky. This just works. That's the easiest. Easiest one I've ever managed. Now, the spec sheet didn't actually give an exhaust peak. This was the same exhaust peak as the standard cam. So, well, let's just check if it lines up with that, because I'm assuming it will. So what we can do now is take our, keep rotating the engine. Till, yep, our exhaust valve starts, or exhaust cam starts going up. Okay, so we want to set our dial gauge till it's doing nothing but going down, so approximately in the centre of the peak of that cam. We then turn our engine backwards to start with. That one full rotation, come up to it from natural rotation. Oops. Gives us 207.5. Now, go back to 0. Now the other side. Two 207.5, 207.5, 293.5, which gives us 250.5, and our exhaust peak is at 250. So we're actually dead on. Nice. That was easy. So I get this lubricated up, and get the front cold on. I'm just going to give myself a start. We'll bend those up. Partly disgustingly dirty pliers. Well, nothing's ever easy, is it? I went to go install this chain tensioner and I realised I didn't have this bit. I thought it came with the kit. And then I further realised I'd already put it in my metal scrap bin. So I had to empty that out and find it. The tension is supposed to go in there between two washers. These are the ones that came with the kit. There's some big chunky 5/16 washers. And it won't fit in there, you know, with those two washers and that, and it will not go between there. So I've got some 1/4 inch ones and I've had to take a file to the middle of them so that they will now go over this pin nicely. So let's get it installed. I'll put my top little pin, split pin in first. I'm tempted to line this stuff up in here. So, right, that's through. Get this tiny little pin in the bottom of that. These tiny pliers. Oh, I'll just spin it round so I'll get a screwdriver in there and split it. There we go. Get the seal in. I'll just pop that on the press and get it done. Right, so let's get this timing cover on. Need that out. Now, with a handy bit of coat hanger, it should be able to hold the tensioner back. Just enough to get the cover over and in place. Right, now I need a double opposite. Can I poke this into the block? So that was a through hole. That one is. That one is. Oh dear. Well, we've got a problem I should have noticed much earlier on. the lowest hole in the ceiling block, the replacement ceiling block, does not line up with the hole on the car. Right, let's get a couple of these bolts in and then see what I mean? Hole doesn't line up. Unfortunately, I do have a spare ceiling block that I had ready for that. So I'm going to pull everything apart. Well, not everything. I'm going to pull stuff apart again, try and swap those over without destroying everything, and then proceed. I've just got the cheesehead screws in this timing cover for the time being. And I also now realise I've got to lubricate the timing chain before I put stuff together. I think what I'll do is I'll stick an oil can down here, because that's the hole through which it all goes. Okay, so I have gone and changed my ceiling block to one that fits properly, so I've been able to get all of this in, and I put all the bolts in for all the fixings in for the timing cover. So this is a stud for whatever reason. Just gone and checked on the Herald. It's in that place. All of those that just go straight into the front engine plate with nothing behind are the cheesehead screws, as is this one down here. And I've gone and put copper washers on that one and that one, because I can see that they are through holes. Right. As well as not lubricating the timing chain, I haven't put the oil thrower on. This is not going well today, is it? Okay, so I've had the front cover off again, lubricated the chain, put the oil thrower in, put it all back. So, as you see, I've got the head studs on, longer ones here, because they are to cope with the lifting eye. And now put in my tappets and get ready to build the head. So these are from the cam supplier. I do like all the way the stuff for this cam has come in oil paper. It's very like the 70s or 60s. And the NOS stuff you can find if you're lucky. Right, with them all in, let's get the head put together. Right, so got my valve springs, collets, keepers and valves laid out, giving them a clean down, valves as well. The new springs, they're the ones, the one again from the cam supplier, because that's what they recommended. And you see, unlike the old ones in my left hand, on the left side, they don't have any directional coils. So we've got different tighter coils at the bottom of the originals, and they're a little bit taller. Presumably, it means they're slightly higher rating, but it could also just be that they are, you know, the old ones have been on the machine for 50 years, probably. The valves are numbered, were numbered by the machinist, which is quite nice. And you can't confuse them, because I've now got bigger valves as well. had this done to late Spit Mk3 spec. So I've got the head, back of the head number 4, front of the head number 1. I'm going to get them in. There's my spring and collets. Oops. Some more space for my compressor. Move them over a bit. Drop one on the floor. That one's in. Bit of a tap. Okay, well, I will do the other 7, and then we'll get the head on the car, which is exciting. Well, we'll get the head on the engine, not quite in the car yet. Right, head is on. Got lifting eye in place. I don't have the takeoff. It's supposed to go there. It was really pretty knackered. I was going to buy another one. Then I thought I had one. But I'm pretty sure I do have one left over from the Herald. Because for the Herald, I put a Spitfire head on it. One of these. And I'm sure it had that attached, and the Herald doesn't use it. Anyway, for head nuts, I'm using these mini items. They're a flanged nut, so they were the later A series, I think, had these. Anyway, you don't need to use a washer, and you don't need to worry about the washers. Getting the hardened washers, getting the hardened nuts, you got the whole thing in one. They come from this, I think ultimately everything comes from the same supplier, because these labels, these part number labels, appear on a lot of stuff I get for Triumphs as well. Anyway. You have to order one of those. So I've actually done quite well, because you've seen I've had several things so far that have slowed me down. Or could have stopped this engine build, but actually I happen to have the parts hidden away. But I don't think I've got that. Or at least I have no idea where it is if I do. So, I'll get the head torque down and continue and get the rockers on. Hopefully this time round the rockers are the right shape. If you're watching when I did the Herald engine, you'll have seen that the rockers were unfinished, not properly finished. So they actually, I couldn't get the if I couldn't put the rocker shaft on without putting pressure on all of the valves, which is obviously wrong. So, even with the adjusters backed all the way off. So this time round I bought fancier rockers, because I was hoping they came from somewhere else and there was more chance of them being better. But They came with one of these sort of labels as well, so I assume they'll come from exactly the same place as the less fancy rockers. Fancy as in I bought the bushed ones you can get, because I was hoping they'd be slightly better, but I think they're probably just the same ones as you buy non-bushed but with a bushing. Anyway, I got the head torqued down, and then we'll move on from there. Right, so the first job this morning is rockers, and I have already had a look in here because I didn't want to. I was going to give up for the day if I found these were wrong. So I bought this bushed rocker set. I found these from Moss. Didn't get it from Moss, but it's got this same label I keep pointing out, so they were absolutely the same place. So these are bushed rockers. Now I did this because when I did my Herald engine, the rockers I bought were incorrect here. So this is an original rocker, and if we put them, actually we put them both on the shaft, that'll be easiest. Too close. If I line up the tips, the back section there is the same thickness. I can't see that very well. Do it by hand. So if I line up the tips and the bores, they're the same at the rear as well. Now the Herald ones I got, or the ones for the Herald, were not. They were too thick in this section. So they also, on subsequent examination, I found that inside the bores they were not particularly smooth either. So I bought these more expensive bushed ones, which I think still probably come from the same place, because everything seems to. Anyway, got these. They look okay. Still frustratingly not an Imperial spanner size there. Kind of tempted to go and scrounge some nuts off the old ones. Is that a bit daft? Probably is, isn't it? Right. Let's get these all off the shaft, because they have some shipping oil on them. I'm going to clean that off. I will go and get the other bits we need to build up the rocker shaft. Get that put together, put it on the engine. Okay, step one here is get all your stuff in the right order before you start putting it together. So I've just done this and then undone it because I put my shaft on, my first rocker on the wrong way round, or all the first three on the wrong way round. So take it apart and start again. So let's do it again. A bit better. I'm not going to make you watch me. So, got a Thackeray washer in there. Rocker on the correct way round. Just double check that. Yes. Good news is absolutely everything is covered in assembly lubricant. Right. Spring. Next rocker. Pedestal. Then we get one of our spaces. Next rocker. Another spring. Another rocker. Another spacer. Fight with the pedestal. And again, this last pedestal gets that Thackeray washer in there. Cotter pin. Then we can pop in some push rods. And get this onto the engine. And just before I get it any lower, I'm backing all of these off as far as they will go, because we are going to open, well, depending on how far up these will actually go, we will open 2 valves, probably. But we want to put as little pressure on anything as possible. So I just want to get those adjusted as far out as they can be. Then this has got to go down, and each push rod has got a seat on. Now, onto a rocker. He doesn't want to move. There we are, we're down. Yeah, see, so as we tighten this down, we're probably going to be opening number 1 and 3, because that one's now tight against the valve, and that one has not a lot of clearance. So this is definitely one of them ones where you want to be going carefully, rather than sticking an impact on it or something. And the problem I had on the Herald, which yes I know I keep going on about, was that at this point there was no clearance on any of the rockers. So you see there we've got loads of adjustment available, which is what we need. Particularly for this camshaft, because this camshaft wants a slightly higher valve clearance than the stock. It's 14 and 16 thou, and it differs between the inlet and exhaust valves, so it's 14 and 16 thou. I can't remember which way around there it is either. I think I'm going to have to make myself up a little plate and find somewhere on the engine to attach it, because otherwise I'm going to be forever looking that up. Okay, let's get them torqued. So as I said, I need to find somewhere to write down my exhaust clearances, or valve clearances. So I've just written it on the inside of the rocker cover, in Dremel. Anyway, yeah, I got this in Job Lot Parts a while ago, and I've been having trouble getting the standard rocker covers to seal on the Herald. So the Herald's currently got Spitfire one, and I thought, why not try this? So I gave it a bit of crackle black paint, and this morning I've just flatted off the ribs, but the casting is not smooth, so it looks a bit crappy there. You can see it, it dips in, and there's not, there's not enough material for me to go very far. So it's a bit 10 feet, but at least handy as a notepad. So let's get these rocker clearances set. So I've also stuck my crank pulley on. because then I can turn the engine to top dead centre. Now at top dead centre we know that 1 and 4 are not going to be doing anything, but we want to be setting our valve clearances at top dead centre on the firing stroke. So our firing order is 1, 3, 4, 2. So right now 3 has the inlet valve down, 2 has the exhaust valve down, so we know 2 has just fired because it's on the exhaust stroke, so that means 1 at top dead centre must be about to fire. So at that point we can set our valve clearance for 1, and for this cam our inlet should be at 14 now. Our exhaust at 16. So now if we turn our engine another 180 degrees, ish, three, there's nothing going on, which we expect. 1 has just fired and opened the exhaust valve. 4 is starting on the intake, so we know we can set 3. And again, back to top dead centre. Now that'll be 4 at top dead centre on its firing stroke. 3 is just fired, got its exhaust valve open. And once more, 180. Exhaust just opened on 4. 2 should now be at bottom dead centre. Exhaust 16. Okay, so we're going to go back top dead centre. One should be free. 14 on the inlet. Right, I need to get the rocker cover on. First, I'm going to make myself a gasket. Then we'll flip the engine over and get the sump all finished off and sealed. Then the last thing to think about, really, other than just putting parts on, will be getting the distributor drive gear end float sorted. Then it's going to be throw on the alternator, the water pump and all that sort of stuff, and get it in the car. Why make a gasket? Because this sheet of neoprene has cost less than you can buy one of these for, and I'm going to get more gaskets than I could possibly need out of it. Now the bit I thought might be interesting here is these inner corners, because my plan is to punch them out. Because what I didn't want to do was cut a sharp corner. Because I imagine that'll be quite weak. Come right through the cardboard there. And the rest is just going to be knife and scissors, so I will get that sorted and then we'll check if it's on the car, and if so, crack the rocker cover on. Well, it looks alright. It's not too... It's probably about the right thickness. Width, rather. I probably would have liked these corners to have been a bit wider, but we'll see how this one goes, and if it leaks, we've got a whole sheet to have another go with. So, let's close this up. That might be a difficulty. Felt like it was catching on something. I mean, it could have been the... hopefully it's the posts. It's not been quite in alignment. I don't think it is. It's not. It's catching. It's catching on the rocker shaft. Which is actually not such a big problem. I'm going to grind a little bit off of here with something, just to clearance it, because it doesn't actually matter if it hits this. Well, we don't want to hit that because we'll probably get some sort of vibration noise or whatever. It's not a moving part, so just clearance this a bit and try again. Okay, so end float here. This, which is our dizzy drive gear, goes in and engages with the camshaft. This sits on top of it and holds it in place, but we don't want this pedestal pushing right up against this gear. It needs to have some movement available. And you do that by your choice of gasket here. So you tend to get in a pack some selection of various thicknesses. But we can't directly measure the end float because it's difficult to get a measuring device in there. So what we do is take a washer, measure the thickness, put the gear in, put the pedestal on and bolt it down. That'll leave us a gap here, and that gap, minus the washer size, is going to tell us how much end float we've got if we took the washer away. And we then need to choose the appropriate number of gaskets to get the end float we want. So if we ended up that our gap there was exactly the same thickness as the washer, or exactly the same size as the washer, we would have 0 end float, and we would just need to add some gaskets. So I'll get that measured. First of all, I will find the studs for the dizzy. Okay, we start off with our washer, 2.22 millimeters. Put it on the drive gear, drop that in. Drop the washer in first. Now I've got to rotate the engine and push down on this until it drops in. Engages with the oil pump, but it's not wanting to do that. Okay, it was just actually wanting to engage really easily. Of course, I shouldn't complain. Right, that's on. Evenly tightened down. Okay, now that feels tight, so we're now squashing the gear and the washer right against the bottom of this housing. We should be able to measure this gap. If you over tighten it, you can feel that it gets uneven. So obviously you're squashing down. That's basically all the feeler gauges are a tight fit, which gives me 2.06 millimeters, which is good. Wow. And that gives us 0.16 millimeters of end float with 0 gasket. And now I bet I'm going to regret measuring this in millimeters because it's going to give it in power, isn't it? Oh, the maximum end float we're allowed is 0.718 millimeters. So I think that's what this is going to mean, is we're going to have no gasket here. I'll put a little bit of Hylamar between. Well, have I got the thinnest of thinnest gaskets? Let's see. I've got that one, which is the thinnest I've got. Would take us over the end float. No, I've not got anything thinner, so this is going to be gasketless. Right, so I've been getting on with a few little bits. Some's fully on. Got the petrol pump on, including its weird little bolt, closed bolt thing. Dome knot it would be, wouldn't it? That goes there because when they're in the car, it's really, really difficult to access that fixing. Got that thing on, and I'm about to go around the front and do the water pump assembly. Now for that, we'll have a look in a bit more detail, because getting these pulleys in line, the 3 pulleys, might need a bit of finessing. Also, the water pump housing fits with 3 different sized bolts, which should be these 3, which are a 818, 819 and 822. They are 2 1/4. Yep. That one's then. No, is that 18? Yeah, 18, 2 1/4, 2 3/8. Yep. And then 22, 2 3/4. Yes. So I'll figure out what order they go on. So that goes on there with these 3 different sized bolts. Now, probably looking at the thickness of this casting, I want a longer one in there, the shortest one in there, and middle in there. Do that. It'll stick out about the same. Ah, no, I know what. That takes the alternator mounting bracket, so that would be slightly longer. So, biggest, middle, and smallest. Right, I'll get that fitted. Then we'll have a look when I get to actually aligning the pulleys. Okay, so my pump is loosely test fitted, and you can see that the lower pulley is further out than the water pump and further out than the alternator, and the alternator is way behind the water pump. So this, I suspect, is probably because we've had to put quite a lot of shims in because of the aftermarket chain gear. So I think what I'm going to do first is get something to hold the rear of the crankshaft with, and that'll let me. I'm not going to try and torque this up to the 100 foot pound or whatever it's supposed to be, but I'll get that tightened down and see if that changes things. Okay, so that made no real difference. So what I plan to do is make a gasket for the water pump out of the thickest stuff I've got, and that'll let it sit that little bit further out. Should give us good water pump to pulley alignment. Then the alternator is going to be a case of shuffling it forward with probably a little extra spacer or washer under here. And I realised while talking about these water pump housing bolts, and this one being our medium one because it holds bracket, this aluminium bracket is probably over twice the thickness of the original, and then if I try and space this further forward again, then, you know, we're definitely going to need to find a longer bolt here. So I'll make myself a gasket. We'll check the water pump still fits, and then start filling with the alternator. Okay, with the chunky gasket, that lineup is now much better. So I'm happy with that. I had to go and scrounge up some longer studs as well because we were at the limits with no gasket. So I put in an extra thick one on, meant I needed long studs. So I think these are the ones I found were off gearbox top covers, if I remember correctly. Anyway, alternator. So it's funny actually because I had to move the alternator back on the Herald. Now here I have to move it forwards. But it should just be a case of undoing this and getting a spacer in between here. We can actually already determine how thick that's going to need to be as well. Approximately. About that much, whatever that is. 1 penny washer will do. And the same behind this bracket, because this bracket's now... Actually, I think the bracket wants to be... Well, yeah, we'll see. Might have to space the bracket too. But that is fine. Okay, well, I'll do that and then we'll check it out. Right, so that is now pretty good. And the alternator could be a tiny bit further forward, but you know, we're looking for pretty good here. So the belt is not obviously misaligned. However, there's another problem. Look, that isn't a flush. In fact, when it was done up before, this bracket was under strain. So that needs to go forwards or backwards quite a long way, which is not great. See, I don't really want to try and bend. Don't really want to try and bend this thick aluminium because I'm not. Don't have a good feeling about it going well. But also, that's quite a chunk of stuff to put in here to bring this forwards. I do have an original dynamo bracket. Just wondering if I might be able to. Nah, I thought I might be able to get that in on the rear of the alternator, but I can't. It's going to have to be this. Because to space that one out would be floating out in space. I guess I will hunt down some suitable washers then. So, one scavenge in the box of stuff that came out of the GT6 to find a nice chunky washer, and a cut down bolt later, and we are there. So, I'll get that fitted fully with some sealant and that, and get the belt on. Oh, the other thing I found in the box, I knew I had a spare one. It turns out I replated it. I'm pretty sure that doesn't belong to the GT6. If it does, I've spent 25 quid on a new one. Okay, there's that to do. Yeah, I don't think anything else before we can take it off the stand and put the back plate in the clutch and everything on. Okay, one last thing to deal with before I think the engine is ready to lift into the car is this. So you see it is quite pitted. So I'm going to take a piece of glass and a piece of emery paper and I'm going to work that down until it's nice and smooth. There's plenty available there to be able to do that. Now this attaches with an 808 and an 814 bolt, which is 1 inch and 1 3/4 inches. I'll get that done. I'll get it on the engine. Oh yeah, the surface it goes to, actually, the guys at the engine rebuilders were able to flat this back because this was similarly pitted. They put it on a grinder that used to be used for facing heads and were able to get that nice and smooth again. So after that, not much else. Definitely nothing that's going to be awkward to put on once the engine's on the car. Okay, so I did start with some pretty coarse grit, but I've just finished off with 120 and gone till I've got all the marks from the coarser stuff out, and that will do. And you can still see there's some little bits of purple, but I'm not going to go any further because we do have enough there to seal. It did seal before with the application of some RTV silicone. However, this will be better. Right, so I'm going to give this a wash off so it's not full of metal dust. I pop that on the engine, and then we'll wrap this up.
So there we go. We've gone from short engine to this. It's almost ready to start, but it is ready to go. It's almost ready to go in the car. So next time, I'm going to get the Spitfire uncovered, put those last little bits on, crank in the rear engine plate, and then get this in the car. And if we're lucky, we'll get it started. So if you want to see that, please make sure you subscribe, because then you'll be alerted when that next episode turns up. But for now, thanks for watching, and I will see you next time.